Welcome to the second installment of the Taproot Apprentice's Introduction to Blockchain. In this chapter, let's look at how the blockchain works. Building trust. One block at a time. How blockchain creates unalterable records. Imagine a world where every piece of information you share, financial transactions, medical records, even votes, is etched in an unalterable permanent ledger, accessible to everyone and resistant to tampering. That's the magic of blockchain, a technology that revolutionizes how we record and share information. Let's dive into the heart of the matter. How this chain of data creates such a trustworthy and immutable record. Building the blocks. Data goes in. First, imagine any piece of information, a financial transaction, a document, or even a digital artwork. This data gets bundled into a block, like a single page in a ledger. Hashing it out. This block gets assigned a unique digital fingerprint called a hash. Think of it as a special code that's like a DNA match for that specific block. Any change to the data alters the hash, making it instantly detectable. Chaining the records. The block then gets linked to the previous block in the chain, inheriting its hash and creating a secure link. This process continues, building a chronological chain of blocks like a digital timeline. The network of guardians. Now, this chain isn't stored in one place. It's distributed across a network of computers, each holding a copy. So, if someone tries to tamper with a block, they'd have to change all the copies on the network, an almost impossible feat. Verifying the links. Every time a new block is added, the network of computers collectively verify its hash and its connection to the previous block. If anything's amiss, the new block is rejected, maintaining the integrity of the chain. The power of immutability. This intricate interplay of data, hashes, and network verification creates a record that's incredibly secure and permanent. Once a block is added to the chain, it's practically impossible to alter it without affecting the entire chain, which would be immediately flagged by the network. Think of it like trying to rewrite a page in a history book without anyone noticing. In a traditional system, someone could sneak in changes. But with blockchain, every edit would leave a glaring mark, exposing the tampering attempt. The applications are endless. This tamper-proof record-keeping has vast applications beyond cryptocurrencies like Bitcoin. From tracking the movement of goods in a supply chain to securing medical records, blockchain is transforming how we store and share sensitive information. Cracking the code. Blockchain's math magic. So, we explored how blockchain builds an unbreakable chain of information. But what keeps this chain secure? That's where cryptography comes in. Think of it as a superpowered lock and key system that keeps everything safe and verified. Imagine three main characters. The data dude. This guy represents any information you want to lock up in the blockchain, like sending money to your friend or recording a vote. The keeper of keys. This is the cryptography itself, with two special keys. A private key for you, like a super-secret password, and a public key that everyone can see, like a padlock combination. The blockchain butler. This hard-working fellow manages the chain of information, making sure everything checks out. Here's how the magic unfolds. Encrypting the dude. Your data dude gets wrapped in a special code using your private key. It's like turning him into a super-secure package with a unique fingerprint. Public announcement. The blockchain butler takes the encrypted data dude and broadcasts his public key to everyone on the network. Think of it as shouting out the padlock combination for everyone to see. Unlocking the truth. Anyone can use the public key to try and unlock the data dude, but only someone with the matching private key, you, can do it successfully. It's like trying hundreds of keys on a padlock until you find the right one. Verification Village. The blockchain butler doesn't just accept any unlocked dude. He checks with all the other computers on the network to make sure they got the same result. If everyone agrees, the data dude is added to the chain, locked and secure. This cryptography magic ensures three things. 1. Security. Only someone with the right private key can unlock the data dude, keeping your information safe from prying eyes. Secondly, verification. Everyone on the network can check and confirm that the data dude is legit, preventing fraud and ensuring trust. Lastly, immutability. Once the data dude is locked into the chain, it's practically impossible to change him, creating a permanent record of everything that happens. Think of it like this. Imagine sending a secret message to your friend using a special code only you two know. Everyone else can see the message, but they can't understand it without the code. That's the power of cryptography in blockchain. Thank you for joining me in this journey of discovery and learning. Next, we'll explore why decentralization matters and the new paradigms this simple concept opens up.